Hello friends, today we will 5 timer IC. It is very important and very in 1971 it is introduced, but till now it is widely popular. And why it is widely popular? Because of two things. First is it's a low cost and ease of use. That are the 2 points, so it's a very much popular. Now we will see, you can see this kind of IC we have having the 8 pins. This notch or circular, you can say semicircle, indicates the upper side of the IC. You can start numbering from here. It is of 8 pins. You can see notch over here like a circle or a dash, something like that. So you can start from left 1, 2, 3, 4, 5 and likewise. So this IC is having 25 transistor, 2 diodes and 15 resistor. Okay, so let's talk about the pin numbers the IC is having. As you can see here, it's a ground, 2 is trigger. At pin number 3 we are getting output. 4 is the pin which is reset, control voltage for the 5, threshold for the 6 and discharge and VCC we are giving at a pin number 8. Now you can see at a ground, this is connected to the 0 voltage or the negative of our battery. Then we have a trigger and the trigger is driven approximately 1.7 volt below VCC. Okay, so whatever VCC we are having, trigger and output is driven approximately 1.7 volt below it. Now we have a reset. Reset driving this input to the ground. Okay, so there is some timing interval we are having. Okay, so reset is connected to the VCC. Now we have the control at pin number 5, which provides the, if we give control access, so it will controls the internal voltage divider. It is having internal, so there is no need to connect any resistor outside it. Okay, so what is a voltage divider? If you want to know that, then please go and check the video that I already posted on my channel. Threshold is the one where you will get the 2/3 VCC, okay? And discharge is giving the path to discharge the capacitor between the intervals, okay? And VCC is nothing but the positive supply voltage which drives the IC, and it is having a wide range like from 3 to 15 volt. You can connect VCC. Now, what's its a working principle? This IC, 555 timer IC, basically operates in a 3 modes. So these are the 3 modes: astable, monostable and bistable mode. So let's talk about this mode in detail. So here we will see a stable mode. This is the first mode of operation. Okay, as its name indicates, unstable. So it is not in a stable state. So the level of output is not stable, means at any time it will go high and it will go low. So what are the applications? Applications are clock, or we can say square wave output. It is giving a train of square wave it will give. So that is the circuit where we require a square wave generator or a pulse we are require. In that case we are using a stable mode of this IC. So what's the connection of it? We will check that. This is how the connection we will have. Here we have 555 IC, 4 is reset directly connected to VCC. Then we have pin number 8 for the VCC. Now at a pin number 1 we connected to ground. 5 is control voltage. Here we connected the capacitor, and that is a 0.01 microfarad. That means 10 nanofarad capacitor it is. We can use ceramic capacitor over here. Then we have R1, that is potentiometer we can use, or else if we calculate the value of R1 we will go with that fixed value. So there is no need to use the pot. But why pot we are using over here, that I'll tell you at the output side when we'll discuss and see what exactly the need of it. And then we have the resistor R2, and that is given to the pin number 7. And likewise we have, so what will be the value, what exactly the output we require, that That is very important because we are getting the output in such a fashion, on off, like high low kind of output we are getting. In that case, what exactly duty cycle we require? So what's the duty cycle? Duty cycle is nothing but the period for which the output is for high. Okay, so that will help us, like this potentiometer will decide the value of this duty cycle and we can calculate these values. So there is a formula, like at a what frequency we require this pulse. So here we require frequency. Here what we are doing, like if we know the frequency, then we will go for the, then we will randomly select the value of R and C, because we need to start from somewhere. So the value of R2, C and frequency, if we know, then we can easily calculate the one variable, that is R1. And 1 by F is nothing but the T, and that's the value of T. So if you know the T, then also it is easy to calculate any one value of it. So now this is T1, which is high, means when the positive high side of the square wave we are getting, and that's the formula 0.694 multiplied by R1 plus R2 multiplied by C. So here exactly the time and the frequency all are totally depends on the R1, R2 and C. So if we use the R1 as a potentiometer and we increase the value of R1, we'll increase the denominator, and that is nothing but to help the to decrease the frequency. Okay, and because they are inversely proportional, and for the in case of T, as the value of R1 increase, time also increase. So here we are, you can see, like for the low, like T0, if we are calculating, there is a no value for R1. So R1 we are not considering in this case, and that will like whatever value we will change, that only effect to change the positive half cycle, not the lower one. Okay, so negative half cycle will remains the same because R2 and C both are the same. Okay, so we will design this circuit on a protest. So let's start now on here. What we are doing, we will select the value of capacitor. Okay, so if suppose we selected the value of capacitor to somewhat like zero point 0.1 microfarad, then according to that we can calculate the value of R2 and R1. So we will put the value over here and multiply that with the frequency to get the value of R2. Now here the R1 is having some relation with the R2. Suppose we selected R2 without considering this equation. We selected this as a 10K, then our R1 will go with the 1K only. Now, so just as we consider C1 and R2 over here, we calculate R1 by the formula, and F is nothing but the 1.44 divided by R1 plus 2R2 multiplied by C. By using that formula, you will get this value, and from F we can calculate T, from T we can calculate T high and T low too. Okay, so we will now just put the values in a protest circuit to get more about this circuit. Here in a protest, let's create new project. As the project is all about the astable mode of 555 IC, we will give the name same like that only. So here we will give the name astable mode, simple. Okay, 555. And we will go next. There is no PCB design for this and no firmware, so we will directly go for. Now you know, like we have to select the components as we have schematic diagram shown over here. We will go with the IC 555. Okay, so here is the IC I have selected. Then we need a pot. So I'm just using a pot, that is a generic device I'm selecting. Then what I need is the resistor. I will go for the generic again, and the capacitor also I need. So I will say capacitor. If you want to know like how to select the components and from where we have to select it, just go and check the video that I already posted on my channel. Okay, so here is the IC. We will just place the IC over here and just zooming it. Okay, so here we have pin number 8 which is connected to the VCC. We will go with that, but before that we will short that with the pin number 4. Okay, now so from this side we will give some input. Okay, so here we will give sine wave. Okay, so sorry, not sine wave require, we require DC. So let's change it to the VCC and give the voltage. So here I'm giving the voltage, as we have a wide range from 3 to 15, I'm giving voltage 9. Okay,
And here I'm using a potentiometer that is of 10K. I'll change that to fixed value of resistor once I get the exact value as we have calculated. So I'm just changing it to 10K. And
so
now
let's
here is
start
the
with the
circuit. You can
simulation.
see like where I have
Okay,
placed
so now
C3,
on the
C4. You
blue
can
you
just
can see
make a connection,
the
and by
waveforms I
using
have
this
connected, that is the
oscilloscope you can
blue.
see the waveforms. Here you can change
Give
the
me a second, I'm just
time,
changing the
here you can
voltage
change the
and time
voltage ranges and
so we
everything.
can
Okay,
easily get a
so this is how the
AC. This is
oscilloscope
how the
will work,
waveforms
and it
are.
is very easy to get more about the circuit and its output too. So this is a stable multi-mode operation of IC 555 we have seen. Now we will see more operations like monostable, bistable too. Okay, for that please do subscribe and press bell icon to get the notification. Okay, and thanks for watching. Please do subscribe to my channel and press like button.